Good afternoon, and welcome to Hand-Wavy Chemistry. Pinnacles National Park is home to almost 40 California condor, and hikers on the High Peaks Trail are often treated to sights of these birds soaring overhead, although getting a decent picture is another challenge entirely. The total world population of these birds is estimated to be only 561, which may not seem like much, but is actually a remarkable comeback as they almost went extinct in the 1980s. In fact, in 1987, to try and save the species, the United States government took the drastic steps of capturing all wild condor, making it extinct in the wild. The 22 remaining condor were put into a captive breeding program, the goal of which was to eventually establish two geographically separate wild breeding groups. The reasons for the bird's decline are multiple, but one major factor is believed to be the use of the chemical DDT. The chemical DDT, which has the preferred IUPAC name 1,1'222'-trichloroethane 1,1-diol bis-4-chlorobenzene, is an insecticide that was widely used in the United States of America in the mid-20th century. It was available to the general public, and its use in both agriculture and the home was encouraged by the government. DDT is synthesized by consecutive Friedel reactions. The reaction starts with trichloroacetaldehyde, which then reacts with two equivalents of chlorobenzene. During these reactions, chlorobenzene is ortho-para-directing. That means substitution will occur either next to the chlorine atom or opposite the chlorine atom, with the para position, the one opposite the chlorine, being favored. As a result of this, the final product is a mixture of isomers. Most of it is the desired para-para product, while the largest impurity is the ortho-para product. At its introduction, DDT was considered a wonder chemical. It was credited with wiping out malaria in Europe and North America, and Paul Hermann Muller was awarded the Nobel Prize for discovering its insecticidal properties. Now at this point, you might be feeling a little bit confused. I started the video talking about condor, and then started talking about an insecticide, or more specifically, a contact poison for arthropods. And condor are not arthropods, nor do they eat arthropods. However, the plants and animals within an ecosystem are connected, and certain chemicals can be passed on and even concentrated through a process known as bioaccumulation. For example, tuna are often described as being high in mercury. Now, there's nothing special that the tuna is doing to become high in mercury, it's just going about its business eating fish. But mercury compounds are not easily eliminated from biological organisms. And so, the small little wee creatures at the bottom have some mercury in them. And then as they get eaten and we move up a trophic level and we keep going up and up the food chain, the amount of mercury goes up and becomes concentrated. And tuna are right up there at the top of this food chain as apex predators, right below sharks. And so they end up being high in mercury. The same is true for DDT. It is not easily eliminated from biological organisms. The half-life for DDT in the human body is estimated to be about 6 years or so. As such, it will spread throughout the ecosystem, going from insects to lizards and fish to larger fish and eventually out into the ocean. It has been observed that even today, condor are still ingesting DDT when they eat the remains of dead sea lions on the coast in Big Sur. But none of this explains how it is that a chemical that doesn't kill birds almost wiped out an avian species. And that comes down to a more insidious and hard-to-notice side effect. DDT and its metabolite DDE cause eggshell thinning. With the eggshells thinner than they should be, when a large bird attempts to incubate its egg, it is more likely to crush or crack it. The exact mechanism for this eggshell thinning isn't exactly understood, but it is both dose-dependent and species-dependent. In addition to the condor, other large birds of prey are also heavily affected by eggshell thinning as a result of exposure to DDT and DDE. And DDT is considered to be a major factor in the decline of the American bald eagle. Meanwhile, chickens are hardly affected by it at all. DDT isn't the only reason for the condor's decline. Another factor that continues to be an issue today is lead poisoning. Condor are carrion feeders. They eat dead animals without too much concern for how it died. Because of this, if someone were to say, shoot this squirrel or shoot this deer, both of whom live at Pinnacles, the condor would happily eat the corpse. And if the bullet or shot used contained lead, the condor will ingest that lead. And over time, the amount of lead in the condor's body will build up until it reaches dangerous levels. In fact, it seems that about 20% of all wild flying condor have or are at risk of developing acute lead poisoning. For this reason, wild condor are regularly caught, their lead levels tested, and if need be, they are treated with chelation therapy. But that is a story for another day. I hope you have enjoyed this video, and if you have, please make sure to like, subscribe, and share it with your friends. And if there is a topic you'd like to see covered in a future video, please put it down in the comment section below. Thank you, and I hope you have a wonderful rest of your day.